Welcome to the channel Physics Made Easy. Today we will discuss refraction through a prism. I am showing you, as you must have seen, this is glass prism. How will you define prism? Prism is a homogeneous transparent medium such as glass bounded by two plane surfaces inclined to each other at an angle. Look, this is one surface, this is other surface, and the angle at which they are inclined, this is called prism angle. How to show it? Today we will discuss what is the refractive index formula for prism, how will you derive, and other conditions when the light ray is incident at one of the refracting surfaces. Look how to draw prism. If you see, this is the triangular section I have shown. If you draw another this surface, okay, then if you join this one and this one, look, these are these surfaces, this one and this one. So this point, suppose this name is A and this point suppose P, then any plane transverse cutting these two surfaces is the vertical section of the prism. Suppose this is the point B and C. Normally we draw the prism like this. This is the figure of prism as I have shown here to show the faces, but normally to derive any relation or to do numericals, we draw the prism like this. This angle is called angle of prism. If a ray is incident at this surface A, P, B and somewhat this is M, this is N, then what happens if the ray is incident at this surface and refracted and emerge out from this surface, then these two are refracting surfaces meeting at an angle called prism angle. Here I will show you that if the ray is incident at this surface like this, okay, then what will happen at this surface? I put its name ABC. If you draw perpendicular normal, then since the ray is moving from rarer to denser medium, prism is made up of glass, its refractive index is suppose mu, then the air to glass, if the ray moves, then it moves towards the normal, it bends towards the normal. If there is no change of medium, how the light ray will go? Light ray will go straight, and this would have been the path of light in absence of glass or any changed medium. But if the glass prism is present in the path of incident ray and this is the angle of incidence, suppose this point is P, then what will happen? The ray bends towards the normal, making angle of refraction R. This is the refracted ray at the other surface AC. What will happen? Again you will draw normal, then you will find that if for the first surface refraction AB, suppose this is R1, and at the second surface refraction, if you see that this is the normal, this angle suppose R2 if you write, then this is the refracted ray making certain angle from the normal. Since the ray is emerging out, it is shown by the angle of emergence, it is called E. E means angle of emergence. So this symbol E in some books I dash is also taken. Now this is the simple refraction at surface AB and AC. Okay. How to derive refraction formula? Look, for the surface AB, how will you show how to write the expression. I am showing, look at the surface AB. If you see this angle of incidence, this is angle of refraction. These are the normals. If you join these two normals, then suppose this is the angle E at which they meet. As this is the refracted ray, then emergent ray is extended back and incident ray is extended forward. Then this angle between these two extended rays, that is incident ray extended forward and emergent ray extended backward, this angle formed between them is called angle of deviation. As per its name, the ray is incident in this direction, but due to the prism, it comes here within prism and it comes out through the prism in this direction. Then since it was moving in this direction, but finally it goes out here, then how much is deviated? This is angle of deviation. Look here, for this point suppose I write Q and this point suppose I write O. Then consider the triangle OPQ. If I show here, this is the triangle OPQ, this is triangle delta angle, this is the point O, this is P, this is Q. What will be the angle P and Q? Look here, this is I, this is R1, this will be I minus R1. Similarly, this is E, this is R2. What will be this angle? E minus R2. Will be or not? Then what can you write? That exterior angle is sum of two angles, angles P and angles Q. Then what can you write here? This angle I minus R1 plus E minus R2. Then what can you write? I plus E minus R1 plus R2. Can you write? So this is the expression for delta. By considering this triangle OPQ in the figure I have shown here. Okay. Now, if you consider the triangle, you take the triangle PQE, then triangle PQE gives you R1 plus R2 plus E equal to 180 degree. And what about the quadrilaterals PAQE? You know, angle P, angle Q made by normal at the refracting surfaces, they are both 90 degree each. So, if these angles 90 plus 90 180, then what will be sum of angle A plus E? They are in front of each other. That will be also 180. So, you can write A plus E is also 180 degree. Comparing these two expressions, what will you get? E 180 180, it will be cancelled. If you subtract, then R1 plus R2 minus A will be 0. What will be A? R1 plus R2. So, in place of R1 plus R2, what can you put? A. Then what can you write? Delta. Delta as I plus E minus A. This is the expression for angle of deviation. Sometimes it is asked to derive the angle of deviation. For a prism, you can derive in this way. What is this? Angle of prism A. Now look how to derive the refractive index of material of prism. Suppose this is the refractive index formula mu. Okay, symbol mu. Then how to derive the expression for mu? You know, mu is always derived by sin I upon sin R. Using this relation, you can derive. But before that, look, in case of prism, what happens that for any particular angle I, there is an angle of emergence E. If you take different angle of I, you will get different angle of E, but there will be one particular angle of incidence for which the angle of emergence will be same. This is called, for that angle of emergence which is same as equal to angle of incidence, the deviation produced by the prism remains minimum. So, for minimum deviation position, angle I and angle E are same. How? Look, if a graph is plotted for angle of deviation and angle of incidence, then it has been observed that graph is obtained like this. And for one and only one angle of incidence, there is minimum deviation. This is called delta minimum. You have to find this value in experiments. For different angle of incidence, you find different angle of deviation. How to find this minimum deviation? By plotting the graph. Other than this value of I, you will see that there are two values of I corresponding to same angle of deviation. Look, this is angle of deviation, suppose this delta 1, you will find this is angle of I1, suppose I write here, then this is another angle, and what is this angle? This is E. You can write here, this will be angle of emergence E1. So, you will find that other than angle of minimum deviation, there are two angle of incidences corresponding to deviation. How to show it? How to find the angle of minimum deviation value? By using this fact that practically it has been observed that I is equal to E if delta is delta minimum. Then put this relation here. If I is equal to E, then what can you write? You can write delta minimum as 2I minus A. And if delta minimum is 2I minus A, then what will be I? You can write here that I will be delta minimum plus A upon 2 from this expression. Also, if this happens that delta is equal to delta minimum, that angle of deviation is minimum, then I equal to E means R1 will be same as R2. How can you say this? You know, mu is same for the same material, for the same prism. Here at the surface AB, what can you write? Sin I upon sin R1. If you write here mu sin I upon sin R1. For AC, what will you write here? If the ray is incident at the surface AC, then it will come out through this surface AB. I equal to E means that if these two angles are interchanged, then if this emergent ray is incident ray, then incident ray at the surface AB it will act like the emergent ray. Then what can you write? That R1 will be equal to R2. Will it be or not? So, R1 will be equal to R2. Suppose this is equal to R. Put here R1, R2 are same. Suppose they are R. Then what can you write? A as 2R. Then what will be angle of refraction? R will be A by 2. Now use Snell's law. Then mu equal to, if you write sin I upon sin R, what is sin I? I means delta minimum plus A by 2 upon sine A by 2. This is the case that you derive, how to derive the refractive index formula for prism. You have to plot the graph for various angle of incidences, and you will find that the graph is not a perfect parabola, except at one point you will find that this gap is little less than this gap. You know, if you draw a vertical line passing through the minimum deviation position, angle of minimum deviation, and other than this angle I, there are two values of I you will find, then one is angle of incidence, you can say, other is angle of emergence. For example, here also you will find the same. You see here that angle of deviation first decreases with increase of angle of incidence, becomes minimum at particular angle of incidence, then it increases. Look again, that angle of incidence is increased in this way, but at the angle of incidence, if you start increasing angle of incidence, you find that this is the value of angle of incidence, then delta 1 deviation is larger. At this angle of incidence, it is smaller. At this, it becomes minimum. Again, at this, it increases. So, first decreases, then it increases. And for one and only one angle of incidence, its value is minimum. I equal to E, R1 equal to R2 when the prism is placed in the position of minimum deviation. Also, it is called that principle of reversibility holds, that if you make this ray as incident ray, then this will be as emergent ray. Okay. Then you can also say that refracted ray is parallel to base. So, in this way, this I delta curve is plotted, and what are the main important points of I delta curve I discussed. Now, we will see how will you find the angle of deviation for a thin prism. For a thin prism, you can write sine I as I, sine R as R. We have seen this is I, and what is this, A by 2 R. Previously, we have seen this. Then what can you write for a thin prism? Thin prism means angle of prism is very small. Then you can write mu as A plus delta minimum upon 2 upon A by 2. So, this 2 will be cancelled. You will get mu equal to A plus delta minimum upon A. So, what will be delta minimum? This will be mu within bracket, this is mu A minus A. So, you will take A common within bracket mu minus 1. We have seen that angle of minimum deviation for a thin prism depends only on angle of prism and refractive index of its material, not on the angle of incidence. You know what is angular dispersion? What is dispersion? Dispersion means that if a white light is incident on a prism, it consists of various wavelengths. Vibgyor, you must be knowing, each color has different wavelength, then each color is deviated in different direction. So, in the prism, each color is, white light is split up in the various constituted colors. We find that angle of deviation for red color is least and violet color is most. What is angular dispersion? If you find this process in which white light, when passes through a prism, it is broken into its constituent colors, that is called dispersion, and angular dispersion is given by theta, and it is measured by violet color, angle of deviation for violet color minus angle of deviation for red color. It can also be written by this relation, that is A within bracket mu minus 1. So, angle of prism is constant. So, you will write same, and if you put mu V and mu R, different color has different refractive index, what can you write? This angular dispersion is A mu V minus mu R. Similarly, another term is dispersive power. This is denoted by omega. How it is derived? That refractive index for violet color minus refractive index for red color upon refractive index for yellow color, mean color, minus 1. This is the formula for dispersive power, or in general it is given by this relation upon this y. If these relations are written by using this one, you can find this relation. See the questions. In this prism, this is the angle of prism. For this figure, find A if refractive index of material of prism is 3/2. Look here, the ray is incident normally at the surface AB, so it will go straight, come at the surface AC. If it emerges along the surface AC, this is called grazing emergence. Then what will be this angle? 90 degree here. This will be also 90 degree here. If suppose this angle is critical angle, for this critical angle, this angle of emergence in the rarer medium is 90 degree and the angle of incidence in the denser medium is critical angle. We have learned. So, why I have set this angle as critical angle? Because ray is going from denser to rarer medium and angle of refraction is 90 degree. Look here, if this is A, this is 90, what will be this angle? 90 minus A. What can you write? 90 minus A plus C will be equal to 90 degree. This total angle will be 90 degree. So, 90 minus A, this angle, and C, this angle, this total will be 90 degree. So, from this relation, critical angle is equal to A. If critical angle is equal to A, what relation do you know? Mu equal to 1 upon sine C. So, C will be sine inverse 1 upon mu. That is, mu is 3/2. So, sine inverse 2/3. And what is this value? 41.8 degree or 42 degree. And you have seen the glass air interface is critical angle 42 degree. Next question. Look in this question. The same material of the prism is, that is, refractive index for the material of the prism is 3/2. For this figure, will the ray emerge out from AC? This surface is AC, this 90 degree, this angle is 60 degree. So, what is angle of prism? As from the figure, it is clear that angle of prism is 30 degree, and you know the ray will come directly again here in this picture also, as it is entering normal to the surface AB. So, at this surface, if you draw normal, then for the surface AC, this angle of incidence, you know this is 60, then this is 30 degree, and what will be this angle? 90. Then what will this angle? 60. Then what will be I for AC? For surface AC, I angle of incidence will be 30 degree or not? Look here, 30, this is 30, 60, and I am writing this, and this is 90. So, 90, 30, 120, this is 60, then I will be 30 degree. Angle made by the incident ray in the denser medium with the normal. What is the value of critical angle for glass air interface? That is 42 degree. Just now we have seen. Here also we can see that this angle of incidence is 30 degree, which is less than the critical angle, that is 42 degree. So, the ray from the surface AC will emerge. This question, which is asked in CBSE exam 2017. A ray of light passing from air through an equilateral glass prism undergoes minimum deviation when angle of incidence is 3/4 of the angle of prism. Calculate the speed of light in the prism. It is given equilateral glass prism, that means angle of prism is 60 degree. Now angle of incidence is 3/4 of the angle of prism, that means angle of incidence is 3/4 of means into angle of prism, that is 60 degree. So this will be 45 degree. Prism is placed in the minimum deviation position. Then you know, in the minimum deviation position our angle is A by 2. You learned A equal to 2R in the derivation. Then what will be our angle of refraction? 60 by 2, that is 30 degree. What is the relation for refractive index of prism? Sin I upon sin R, that is sin I is 45 degree upon sin R, that is 30 degree. What will you get? This relation sin I upon sin R is also given by C upon V. This is Snell's law, which is used in derivation of Prism formula, and here also C upon V. C is the speed of light in air. So what will be V? You know, how will you write V? V will be equal to C, that is 3 into 10 to the power 8 into sin 30, that is half, upon this sin 45, that is 1 by root 2. So in this way you will find the relation, that is the value of speed of light in that medium, that is V equal to, calculate the speed of light in the prism. So in the medium of prism, speed of light is 3 by root 2 into 10 to the power 8 meter per second. Today we have seen refraction through prism and various numerical problems. I hope you must have enjoyed it. Thank you.